Okay, again, this module, this 4 learning outcome is important. So test 1, question 1, question 2, test 2, question 1, question 2, final, question 1, question 2, question 3, question 4, 5, choose one. Okay. Okay, now today we're going to look at very micro scopic kind of dimension. Then we'll start to look at chemistry dimension, very molecular atomic kind of dimension. So we look at electron structure, periodic table, what are the molecular force, and then the bonding between atoms. So basically, it's a refreshment or recap of your chemistry class. All right. Now, history. This person, Democritus, he discovered. So he introduced the word atoms. His word atoms. That era they don't have microscope. But philosophically, he proposed that actually in this world, in the material, there's another dimension called atoms. Then it further develops. The history went on, and then people found out some parameter. People quantify it. So this table is important because all these value won't be given in the assessment, won't be given in a test or final exam. We assume you know, or sometimes it will given in a question. So for example, you know that in your chemistry class, you learn you have electron and you have proton and neutron inside. You learn about this one. So then there's a mass of so and so value in a gram, 10 power 28, 24, 24. Okay, electron is 10 power negative 28. Inside here is 10 power negative 24 gram. Then charges is also important. Charges, you know, electron is a negative charge. So also in the dimension 1/19, the unit is column C. So the charges of negative and positive must be balanced. They also in the terms of 1 minus 19 column. So these two have to have a stable atom, the charges should balance. The electron also must balance with the proton and neutron. Right? If not, then reaction will happen. Chemical reaction will happen. So if everything's stable, then nothing happen. If more electron or less electron, then chemistry will happen. Chemistry reaction will happen, and so on. Right. So we start with the model. So this is just a relative picture. How big is the radius of electron? Right now, in secondary school, you draw orbit and all this, but when it comes to a higher level, actually the electron is moving in the sphere, and it was fluctuating and it was moving around here. So there is no like one orbit like a planet and so on. So it will move scatteredly with vibration, right, around the circular motion. Right, so it can be oval, it can be, and so on. Okay. So the distance, the electron from the proton actually is quite far. So the radius of the electron, as you can see from the diagram, is 100 picometer, which is 10 power negative 12 meter. The radius, 10 power negative 12 meter pico, right? And then the radius of the proton is 0.01 picometer, so very small. Okay. So when you look under very high advanced instruments, you can, if you study quantum science, you will see something like this. So you'll see like inside here got like an egg yolk, and then outside got one more layer for the electron. Meaning the electron is spread across this one. Right? So why you seeing this one? Because the electron was circulating in a very high speed. So you'll see like a tire like that. Okay. So they already have technology to control the movement of atoms, right? So this is the video. Let's watch like about 1 minute. So this movie actually have a music, but somehow when you connect your HDMI, then it will come out like that. Maybe I'll adjust it. Okay. So you see how human manipulate the movement of the atoms in IBM research. So by having this manipulation, they're able to produce a very high advanced processor for your phone and also for your laptops. So um, I hope this video can inspire you on how people manipulate the atoms, and maybe in your time you can use this technology for biomedical to cure some cancer cell and so on. Right? Let's read. So first important slides for your test one. Normally, you introduce you or ask you to draw a Bohr's model, B-O-R-B-O-H-R. A Bohr's model means we expect you to draw uh, the nucleus and orbital electron in your answer, right? So the first thing for today is Bohr models. So we expect you to know how to draw the Bohr's model, and this one also you learn in your chemistry class already, right? So I'm not sure about overseas your secondary school uh, curriculum, but in Malaysia you learn about this one in your chemistry class in your secondary level, right? So here we will use the sphere to represent the nucleus, and then orbit the circle to represent the orbit for the electron. Okay, and then the electron we use a small dot to represent. So this is a Bohr's model. This is not a Bohr's model. Bohr's models, they are sphere and circle. If you use a cross, it means something else. It's another model. Okay, so Bose model is a circle. Everything is circle. Everything sphere. If you use cross, it's not a Bose model. It's another name for that. It is one type of the Bose model, but normally, if you see the question asks you to draw more models, you have to draw sphere and the small dot. Okay. If you use the cross means is more on the schematic chemistry reaction where there is an electron bonding later. That is for covalent bond, single bond, double bond, that one. Okay, but for Bose model, it doesn't use cross because a Bose model it consider the calculation for the force of the electron and the weight for the molecule or atoms. All right. So this one you already know in your chemistry class, but just need to emphasize that Bose model, it looks something like that. Okay. Okay. Now we start with your chemistry class where a thing called atomic number. So atomic number with its Z represent like Z. Z is the protons number, right? Z is a proton number. Proton is a positive charge element. So it's within this one. So every time you see element inside the periodic table, when you see number 6 on the top, it means it's a proton number, it's an atomic number with Z, right? So, and then another one is called atomic mass unit, AMU. So AMU is the numbers below the chart. In this case, carbon. Carbon have 6 proton with Z equal to 6. And the atomic mass unit AMU equal to 12.011 gram. What does this number mean? It means that 1 AMU is 1 over 12 mass of carbon atoms with 6 proton and 6 neutron. Okay, so this is all the definition for a periodic table, numbers that you see in the periodic table, and it will help you in your calculation. Of course, you don't need to memorize all these numbers. You will be seeing periodic table in your assessment. But but what is important, you understand the numbers that you see in the periodic table. Right. Okay. Another one is mass number. Mass number is the combination of proton and neutron. Okay, we use A is a mass number. Okay, so this is atomic number. Okay, don't be surprised if your test one you see this one and then he asks you some very basic question just to help you to score some marks. For example, question 1, section A kind of question, very easy question to score. Just to write what is the mass number, atomic number, and so on. Okay, so very easy, but don't be surprised that some of you might not able to answer. You might confuse this one with electron later. Because as you learn more and more, your brain will tell you this one is electron. So just take care of this one. So first class, maybe you are still fresh, but as we go deeper, we are dealing with electron later. And there is a relationship between Z and E numbers later. So you might confuse with the Z. Okay, so go a bit more. Okay, so sometimes you see 2 numbers. Okay, when you see 2 numbers, on the top one is no longer atomic number, but it become a mass number. Okay, it depends on the presentation you see. If you see 6 and see 12, 6 is a different presentation already. Yeah. So the position not necessarily mean that it will fix that things. So if you only see one number is a Z number or atomic number, but you see 2 numbers on the top, like for example, this 12 is a mass number, and below one is the atomic number. Don't confuse with this one. Okay, so this is very basic. Then we move on. So Another one is recap. What is isotopes? Isotope is the one have the Z value. Okay, you can have element A, element B, element C, and maybe you have A, B, C, D, E, and F, or same presentation. You have A, sorry, you have B, D, and F number. Okay, so if your proton number is the same, for example, B, D, F, if they are the same, then they are called isotopes. Okay, so if this one is the same, they are isotopes. Means they have the same proton number in the nucleus. It depends on the electron. Yes, like you say, it can be different numbers of neutron and electron. Okay. So same. Sometimes I ask you, give the definition of isotopes. So this is what we expect from the answer. You can write something like that, and then define what is A, what is B, and then you give another element, then you explain B equal to D. If you're not able to memorize this one, important is you're able to explain the concept. Okay. Maybe within two lines and a few numbers, you're able to explain what is isotope. Okay. Okay. Example, hydrogen. This one again, this is Z. With one number, one is a Z number. Okay, it's a proton, one electron, and then this one is AMU number, 1.0079 gram. So if you can see this one, neutron will have, it depends. So for example, isotope of hydrogen, you have different hydrogen families. So you have protium, deuterium, and tritium. Okay, so each one of that have one proton, but different number of neutron. For example, protium don't have neutron. And electron outside have one. This one also have one. This one also have one. Okay. Now, why you seeing one electron? Because we assume this element is stable. So when it's stable, the proton numbers will equal to electron number if stable. Okay. Right. Now, throughout this module, if you are given a question, asks you to give example, usually you need to answer like 3 answers for that kind of question. Like give example of isotope, then at least you memorize 3 examples, right? Give an example of metals and so on. So the way you write chemistry, you write also, for example, protium 1,1, deuterium 2,1, and H is 3,1, for example. Okay, so you should able like to draw the Boss model if you are given a chemical symbol. Okay. All right. So another one is AMU again. AMU, everything was referring to a carbon atom as a sample, right? So one question, how do you find the mass of one atom in 1 gram? Here, you have 12.011 gram, right? So you have one carbon there, right? And you have a mass of 12.011 gram. Now the question asks you, what is the mass of one atom in gram? With an Avogadro number, with the Na number. So this number, it means what? 1 mole. chemistry, we always look at 1 mole of something. Okay, so the numbers of 1 mole equal to 6.023 10 power 23 atoms. That one you have to memorize because it won't be given in the test. We assume you already know. Like gravity lah, like gravity number. So Avogadro number 6.023 or 02 10 power 23 is an amount of numbers in our calculation. Of course, by the advance of technology, this number might not be correct anymore. But for textbook, yes, we still stick at this number. Okay, because with more advanced instrument, you will see more things, more detailed things in atomic dimension. Okay, but for example, we are studying engineering. We are not material scientists, so it's sufficient for us to use this general number. Okay. So remember, Avogadro number. Sometimes we don't give in a exam question. 6.02 10 power 23 atoms. So if you're given an Avogadro number, what is the answer for carbon? 1 carbon atoms? How many gram? 1 atom of carbon. Many grams? Are you able to calculate? Or what is the idea, or what is the steps that you? Okay, you take this number, divide by this one, huh? Yes. So it will be some number 10 power something, right? Okay. So again, the yeah. So the rest you know. So at the end, you just take it. What else? Yeah. So the rest you read, huh? As you read, you just take 12 point something divided by 6.2 10 power 23. You get the weight of 1 atoms. So this is normally is the first step every time you come across a question, ask you about something, some reaction, especially when it comes to composite later or metals composition and so on. And yeah, okay. So the other things you just read through 1 mole and so on. Okay, so sometimes the question will use relative atomic mass, molar mass, or atomic weight. Is this one? This number, it can be have different textbook or different authors. They will use different prefer name. Prefer. So actually, they are the same things. Okay, some textbook even use a longer name, average relative atomic mass. This one normally in a chemistry engineering class. Okay. Okay. So we come to application of what we learn. Okay, so we give you an example. For example, ferrum. So ferrum, you have a lot of isotopes. So you learn about the ideas of isotope, which is the Z number is the same or proton number is the same. So as you can see from the example here, when you see one number there, it means that on the top one is the atomic weight, this one. So it gives you the different numbers and with the percentage. So it asks you to, this exercise to ask you to find the AMU number. So the scientists find this isotope have a certain percentage, but you add this number up, you get 100%. You take 91 plus 5 plus 2 plus 0.2, you get 100%. And this one have this mass, this one have this mass, this one have this mass, this one have this mass. So what is the average value that you use for the periodic table or for general calculation? So you need to find the average atomic mass. So what you do is that you take the percentage of something, you change this one to fraction. This one is 0.9 multiplied by this one, plus this one converted to fraction number, right? Multiply this one and so on. You add, you get the, and then you Yeah, and then you divide lah. Okay, you add all this. Okay, then you get you remember, or this one is just I already do this step in the previous steps already, where I convert to fraction number, right? So at the end you get 55.8 AMU for ferrum. So that's why you see this number in the periodic table. Okay, so this kind of question might come out in your test one, question one kind of question, right? You just want to test your basic understanding in finding the AMU. Okay, they give you a list of material, then you find the numbers. Okay, so when it comes to final exam, maybe this information is important, or this step is important when you dealing with mixing or when you do treatment and so on, for composite or for strengthening mechanism later for metals. All right. So we already covered AMU. What is the relative atomic mass of iron? It will be the same, because basically they are the same meaning. Average atomic mass and relative atomic mass of iron, it will be the same. Sometimes we did ask you some stupid question. We might ask A is this one, B is this one. Actually, they are the same answer. You might be confused, how to find this one. Actually, you just copy. Your answer is like, answer is the same as section A, equal 1955.8 something. Okay. So this one you refer to periodic table, which is this one. And this periodic table is available in the Canvas. You can download, and maybe you need to use it throughout the semester. Okay. So this is a very detailed periodic table, where with the different colors and will help you in your calculation. Okay. In general, you have metals, metal with two colors with main group, transition, inner transition. So later we will look at what is these three means, and then metalloid and non-metals. Okay. Okay, the rest you read. Okay, for example, the calculation just now is 55.85. So we already show you how to get this number, right? Of course, you try to review the question and try to think how we reverse the question to ask you the percentage. For example, we give you this periodic table at the back of the question, and then we ask you the missing information. For example, we give you 4 elements, they are isotope, and then maybe we ask you what is the percentage of this element. We give you the final answer. We expect you to reverse the engineering to find that particular element in the planet. For example, in the planet, we have 4 elements. And then what is the percentage of this in the planet, in the known archive, material archive? So you reverse the engineering, meaning you do the same steps, meaning here you know the answer already. Something will be missing inside the steps here. So you just rearrange, then you get the answer lah. Okay, so that would be the way of we ask you the question. Okay, so here also recap how many atoms are there in this 55.8 grams. Is the Avogadro number lah. Okay. Then how many atoms are in 1 gram of ferrum? Yeah, so 1 gram of atoms. Yeah. So this. Yeah, correct. Yeah, you take this one divided by this one. Okay. So the answer is 1 point something, 10 power 22, and so on. Okay, yeah? So this step is just a recap, and why this one important for later chapter when you need to mix 2 elements together to form a new material. Okay, so another one is what is the mass in gram for 1 atoms of ferrum? Okay, so you take again, it's a reverse of section D kind of question, right? Based on answer in part E, what is the mass in gram of 1 mu? Okay, so it's the same lah as A. Yes, it's the same. Actually, it's the same. Mass in gram and 1 mu actually is the same thing. Okay, it's just some text or question. So here, average is 55. In part E here, gram, one atom is so and so. So mass in gram of 1 AMU. So you take mass and AMU, you divide, you will get 1.661 minus 24 grams. So it's just playing with the words. It's just playing with the words. Okay. So F1 is how many grams per AMU? So you take your calculation in gram divided by the AMU number. Okay. So these are the way we ask question lah. So just be sure of what is the question actually want you to do. Okay. So example 2, just now example 1 will be very direct. Example 2, maybe you need to find the x and y just now, right? So you have a formula compound. You have a compound formula. You have ax and by. X and y, they are a simple integer. Simple integer means they are a full number. Consists of percentage of nickel, percentage of aluminium. What is the simplest formula for this nickel aluminide? So how do you find? Or what step should you suggest for this kind of question? Yeah. So how you solve this question if okay. Okay, so first step, what do you write? Okay. So this one you have to follow the numbers. You cannot like round up the numbers. Okay. So the first step you write 42.04 for nickel and 57.9 for aluminium. Then you round up, you make them into a full number. This is actually you round up and then you make the full number. So you use this trick. You convert the question into one amount that you can know, because percentage you cannot count one. I mean, you cannot weight it. You cannot quantify it. I mean, you cannot like quantify. So what you do in chemistry, normally we will either use 1 mole or weight. In this case, 1 mole, normally if you use mole, it will ask you numbers of atoms. So what Avogadro number, we're not going to use 1 mole. We use, sometimes you use 1 kilogram, but in simplest case, we use 100 gram. So there are two approaches. One, you use 1 mole with Avogadro number, okay, number of Avogadro, or you start with 1 kilogram or 100 gram to calculate. Means in one quantified numbers of physical form, and then you find what is inside here. Okay, you assume that okay, let's say you have a sample size of 100 gram. So inside 100 gram, inside here, so you have two elements. You have 42% of nickel and 58% of aluminium. So with this ratio, then you should able to convert this one into mole. The trick is you make a quantified space, then you have percentage, You have percentage. You can convert this one percentage into how many gram of nickel plus how many gram of aluminium, right? Then once you have how many grams, let's say I put A and B. So just now you learn about what? Nickel, inside below there you have one AMU number, right? Aluminium, you refer to periodic table, also have one AMU number. So by take this number, you take this one over this one over this one, you get how many mole of this one and how many mole of that one. So this is Y, sorry, this is X, this is Y. Okay, so these are the general concept. Right, don't chase after the numbers. As long as you know the step. Okay, first step, what should I have? You quantify the things, either in mole. This question don't give you mole, so you have to think like, how do I get mole? You start with something that you can measure, let's say 100 grams or the volume that you know. So in this case, we use gram, 100 grams, then you convert into percentage. So here we have 42 gram of nickel, and then refer to periodic table. So one, you have nickel and aluminium. Are you able to spot where is nickel? Okay, which row? Where is nickel? Row 4, column. This is column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, okay. So you have column 10, row number 4. Okay. And aluminium also, huh? So aluminium, you have 26 something. Nickel, you have 58 something. Okay, so you copy from there. You put inside the answer. Okay, so there's a marks for these two. As long as you extract number from a standard table, there's a marks for there. So remember to write and don't miss the opportunities to secure the marks. Of course, you can substitute in a step later, but it's better that you write it in your answer. Okay, so you convert into mole. So for example, nickel, you take 42 divided by 58, you get 0.7 mole. You do the same for aluminium. Okay, you get 2 mole. Okay, so then you have the total mole of 2.864. Means inside here, inside 100 gram, the total mole you have is 2.684 mole. Okay, once you have that, you can calculate the X and Y. Mole fraction, you take total mole divided by the nickel mole fraction. You get one number, 0.25. And of course, without any calculation, you know the next one will be 0.75. Okay, it must be 1, it must be 100%. Okay, so there's a mark here, there's a mark here, there's a mark here, mark here. Okay, it's an easy score kind of question, right? So you write your y, x and y in the form, but this one is fraction number. We tell you that they are simple integer. So convert this one into full number. So you divide this one 0.25, divide this one 0.25, this one you get 1, this one you get 3. Makes sense. Yes, Ni. Even though you didn't write 1, you write Ni, also give you correct. Ni, LO3. Okay. But your answer, since the question asks you what is X and Y, is better you write X equals something, Y equals something. Okay. Makes sense. Okay. So we slowly progress to a more advanced or more difficult equation. So slowly you start to make up your mind. So there's a difference between the presentation of things in the periodic table, and then there's a certain SOP steps before you start solving. So we deal with mole equal to a certain number of atoms. And then if you're unable to solve it, then you quantify it, put it in the box of 1 kilogram or 100 gram, right? But when you come to metals chapter, you won't deal with 100 gram anymore. You'll deal with 1 kilogram because it's heavy, right? Okay, now we start to go into electron structure. So we look at Planck theory and electromagnetic radiation already. Okay. So the rest you read. And the speed of light also, a value that we assume you know is 3 × 10⁸ meter per second. So there must be an energy for the radiation to happen, right? Okay. So electromagnetic wave, you have a wavelength of so and so, frequency, speed. So these are the things that you quantify electromagnetic wave. You use by wavelength, frequency, and speed. So there's first equation for today. C equal to F lambda. C is the speed of light. So normally this is a constant value that we assume you memorize. 3 × 10⁸ meter per second. Okay, frequency and lambda will be given in the question. Okay. So this one you've seen before also in your chemistry class or in your physics class. So you have a wavelength, you have a frequency, you have type of radiation. So this table is important. Of course, if this kind of question come out, you will see this table. Or you'll see another table, I'll show you. So you in your answer, you can either, your answer can be either in frequency or in lambda. Let's say your answer come out in somewhere here. You are generating an infrared radiation and with the wavelength of what? Okay, so of course we don't expect you to memorize all these number, but we'll give you a table so you should able to refer to the correct one. Okay, so some of you might have difficulty reading the scale, right? So as you move backwards, the frequency here is reducing. So this one is 10⁻11. So this one is 1 10⁻12, and then you keep reducing, but this one is increasing, right? This is 10⁻5, 10⁻6, and so on. So it can be in the light form, spectrum. We call it spectrum. Of course, in the test, you know, like your exam paper is black and white. But what is important is the word here. You won't see the color in your final exam or test. Or test, maybe you still see color because I print it out, right? But in final exam, if this kind of question come out, what is important is the wording above and below the diagram. Okay. So the question in the section C, after you calculate, you ask you what color that you expect to see in visual or in experiment. Like you done the experiment and then calculate the frequency or the wavelength. Let's say the value landed somewhere here. So it's about red color, red and orange, very near to the red color. Okay, so it's either it's a mixture. If your value fall in the between the orange and red, so your answer will be is a mixture of orange and red, but moving towards the red, for example. Okay. Okay, then there's another visual tools that it combine the first first diagram and second diagram, they put everything in one photo. Okay. So again, your visual light is this small section only. So maybe the answer in section C, your answer, maybe you need to answer already is visible light or is in the microwave form, either in towards the X-ray or towards the radio frequency. And as you know, on the left, as it moves towards the left, it will be more harmful to your body. And as towards the right, it's still harmful, but is for communication purposes or application. Okay. And nowadays we're able to use visible light for telecommunication already. We're able to send video file through the visible light dimension. Okay. Okay. Another one is energy. So energy of a single quantum energy you use by Planck number h to help you to find the energy. So once you have the C equal to F lambda, you can calculate F multiplied by h. H is a constant value, where is 6.63 10 power 23, 34 joule. It's the energy, joule per second, joule dot s, frequency. Frequency is in hertz. Frequency is in hertz. Hertz is 1 over time. Okay, so when you take h, this is f. When you take h multiplied by f, you get the energy. You remove the time dimension. Okay, so two important calculation for today. So basically, you have to understand C and H. You need to memorize. All right. Normally, it will give you the lambda. You calculate the frequency. From frequency, you calculate the energy transmitted in the system. Okay. So this is a integration of what you learned just now. So this equation, you have 4 dimension: energy, speed of light, wavelength, and the Planck number. Okay. Okay. So before we move to the Mohs model of atom, we will stop at this slide, and then we continue 11. Okay, 10 minutes breaks.